Hello again. Here we are looking at inverse functions. And if you worked through the first video that I made, remember that we took this function, f of x equals 2x plus 1, which is invertible because it's a straight line, and it passes the horizontal line test. And we wanted to find the inverse of the function that reverses the effects of this function. And we went through our process. We replaced f of x with y, we switched the x and the y, and then we solved what equation we got for y. There we go. And that gave us the inverse function. Right? So the inverse of 2x plus 1 happens to be x minus 1 over 2. And I said, okay, how do we know that this really is the inverse? And I gave an example, right? Here's the function, the original function. It turns a 1 into a 3, right? If I plug in 1 up here into x, I get 3. Well, if I plug in 3 into this inverse function, I get 3 minus 1, which is 2 over 2. I get 1. It reverses exactly what this function did. But how do I know that this would be true no matter what number I plug in? Because it has to be. If this is truly the inverse, it shouldn't matter what number I plug in here. Right? This inverse function should always reverse the two numbers. If 1 goes to 3, 3 goes to 1. If 5 goes to 11, then 11 better go to 5, but I can't test every possible number. There's too many numbers. Okay. Let me see how I would actually do this for all numbers. Okay, so we take our function, right, which remember is 2x plus 1, and our inverse function, which is x minus 1 over 2. What we're going to do, we're going to take the convolution of this function with this function. Now, if you remember what that means, the convolution of f with f inverse is this, which basically says take f inverse x minus 1 over 2 and put that in the x for the original function. So here we go. 2 times, and I usually write parentheses, I'm going to put this guy here right inside these parentheses. And then finally, right, that was just this part, 2 times x. I replace the x here with this whole thing, the entire f inverse. That goes in here. Don't forget the rest of it, plus 1. Okay. Simplifying, the 2's cancel, and I get x minus 1 plus 1, which equals x. There it is. I showed that when I take the inverse function of x and then apply f to it again, I just get x back. In other words, you can think of these things, they kind of cancel each other out. The function and its inverse, they cancel each other out. That's the nature of the inverse function. Now, to show this for sure, we actually also have to do this as well, which is the same, except now the inverse function, right, is eating the original function. So this is just going to be x minus 1, right? X minus 1 over 2 is the inverse function. I replace the x with this entire function here. So I get 2x plus 1 minus 1 over 2. Let's simplify. 2x plus 1 minus 1 over 2. And 1 minus 1 is 0. 2x over 2, well, that's just equal to x. And that's how we know for sure that this function, f inverse of x, truly is the inverse of this function. Because both this, f of f inverse of x, and this, f inverse of f of x, those are both equal to x. They both cancel each other perfectly. So that's it. We've just proven that this function and this function are inverse functions.